Dear students, welcome to today's session. Today we are going to discuss about protocol suite, especially OSI model. Right. So before getting to the OSI model, we should know what is meant by protocol architectures. So why do we need a protocol architecture? Because we have different kind of machines, right? Different kind of machines in the sense Mac based systems, Windows based systems, Linux based systems, right? So in order to establish a communication between different kind of machines, we need a standard protocols or common set of rules to follow. So that irrespective of their hardwares and softwares, computers can able to communicate among them. So that's why we need a protocol architectures, right? So that customers don't need to stick to the specific vendor, right? So initially, Windows-based systems can communicate only with Windows-based systems. Similarly, Mac-based systems can communicate only with Mac-based communications. So, in order to remove all those kind of non-standard communication protocols, standard protocol architectures have been evolved, right? So that the vendors have to follow while manufacturing the hardware and softwares, so that irrespective of the architecture, hardware and software, the machines can be able to communicate, right? So there are basically two standard protocol architectures that exist. One is OSI reference model, and the second one is TCP/IP protocol suite, right? So TCP/IP protocol suite is most widely used because it is it was introduced way before OSI model, right? TCP/IP protocol suite was introduced in the year late 1950s, right? Whereas OSI model was introduced in 1980s, right? So TCP/IP protocol was introduced way before OSI model, but for reference purposes and for understanding of functionalities, layer functionalities, we are still using OSI reference model to understand the functionalities of each and every layer, right? Another approach is there actually, IBM system network architecture, but it's proprietary to IBM system, right? So now let's move on to the topic, OSI reference model. See, OSI stands for Open Systems Interconnection, right? OSI stands for Open System Interconnection. The reference here means to say that it provides a general framework for standardization. So it provides the standard set of protocols to be implemented, right? So that all the machines in the network, right, computer networks, can be able to communicate irrespective of the hardware and software, right? It has a well-defined layer set, right, and each layer has a defined functionalities, right? And it was developed by, the OSI model was developed by the International Organization for Standardization. Simply you can call it as ISO, right? And it was accepted by the forum ITU, International Telecommunication Union. So it has a set of 7 layers, right? And it was introduced in the year 1984, right? As I said, after the introduction of TCP/IP protocol. So that's why we are still using it as a reference model, right? So the open, here the open system interconnection, the word open denotes the ability to connect to any two devices which conforms to the reference model. That means any two systems that conforms to the standard protocol structure of the OSI model can able to communicate in the computer networks, right? And each layer has a set of subset of required functionalities and well-defined interfaces, well-defined functionalities. Each layer provides services to the next higher layer, right? For example, physical layer, if you look at the bottom-up approach, physical layer will provide service to the data link layer. Data link layer will provide service to the network layer. Like that, it will move on, right? So the layer specific, layer N. So generally, the layer specific standards has some set of internal ports as well as some addressing ports or access points, right? So the rectangular box will define the boundary for the layer, means it has some service definition, that is functional description for internal use, right? Internal use. And if you want to send a packet from your machine to another machine, the addressing port will help you to forward the packets. Then each layer has a specific boundary and the functionalities, specific functionalities. So you can do whatever you want within the boundary and within the functionalities. The elements of standardization. The next one is the elements of standardization. So here the elements of standardization is nothing but two layers on two different systems. Same layer, for example, same layer on two different systems can communicate. For example, physical layer from system A can communicate with physical layer on system B. Similarly, network layer on system A can talk to network layer of system B, right? But it cannot talk to other layers of system B. So same layers can communicate with the same layer on the identical systems, identical layer, right? And this is how the data will flow through the layered structure of OSI model. See, the message is given from application layer to physical layer, application layer to presentation layer, presentation to session, session to transport, transport to network, network to data link, and physical layer, right? So the physical layer to physical layer of system A to physical layer of system B will be linked by communication medium or communication channel. The communication channel can be either wired or wireless, right? Wired or wireless. So as I said, a layer to layer communication is nothing but application layer of device A can directly communicate with the application layer of device B, right? Only the identical layers can communicate, right? Identical layers can communicate. You can transfer the data from application layer to the presentation layer, right? So next we will discuss about the physical layer, all the layers one by one, right? First one is physical layer. So physical layer is most important layer in computer communication, because physical layer will provide the actual interface for transmission of information, right? So physical layer will convert your data, right, or PDU into suitable format for transmission. For example, if you are using copper wire as the transmission channel, right, you have to convert it into an electrical signal, right? So your message should be converted into an electrical signal, right? Or if you are using an optical fiber, your message should be converted into a light signal. So basically, physical layer functionality is to convert the message as a stream of ones and zeros into a form convenient for transmission. It can be electrical signal or magnetic signal or wireless radio signals, right? So This level is mostly hardware oriented. Physical layer is mostly hardware oriented, and it will be implemented as a network interface card, right? And the types and lengths of cable, voltage characteristics, right? And it has a set of specific protocols for actual transmission, right? That is, for example, Ethernet, FTDI, fiber distribution and data interface, RS-232, ATMDS. This physical layer will provide service for the next upper layer, that is data link layer, right? Data link layer. So data link layer, you have to convert the information, right? Instead of bits, you can consider as bytes, right? You can know that bridges operate at this level, right? Bridges operate at this level, and data link layer is basically divided into two sub-layers, right? Two sub-layers. One is logical link layer, another one is MAC layer, right? Media access control layer. So the main functionalities of data link layer is to encode and decode the bits, right? To map the MAC addressing, right? Or physical addressing of sending and receiving devices, right? And to avoid collisions while transmitting the data, right? And to recover in case of any errors in the received data. These are some functionalities of data link layer, and it also handles synchronization between the sender and receiver, right? So the receiving device must know where the transmission starts, the receiving of first bit starts, and when the transmission of last bit ends, right? So it has two sub layers: logical link control layer and media access control layer, right? So media access control layer will be used to access the media channel, right? MAC layer is basically to access the channel and to transmit the data without any collisions, right? Without any collisions. Logical link layer is basically to synchronize between to establish to provide the synchronization between the sending and receiving devices and for error checking, right? Then network layer, third layer is network layer. The network layer is very important, and it will use store and forward method for routing, right? The main functionality of network layer is routing, and there are two types of routings possible: connection oriented, connectionless, right? Connection oriented and connectionless. We will discuss about those functionalities later part of the syllabus, right? So building routing tables, troubleshooting the routing tables when there is a lot of traffic, or if connection goes down, or if there is any device left out of the network, right? All this traffic related information will be handled by network layer, right? Network layer. So network layer is the third layer of OSI reference model, and the fourth layer is transport layer, right? Transport layer will be responsible for end-to-end communication, right? End-to-end communication. Transport layer is also the heart of OSI reference model. Heart of reference model, right? And it will ensure the end-to-end communication from device A to device B, right? So it does it also does higher order error checking, right? Higher order error checking, and it does make a communication transparent, right? The higher layer, that means the higher layers don't know the data came from another computer. The higher layers means the presentation, session and application layers doesn't know that the data came from another computer, right? And it will do the higher level error checking, and it will console all the data that is received from the lower layers, and it will be appeared as a single message to the application layer, right? And also the additional responsibility of network layer is to look for some acknowledgement that whether all packets are received correctly, right, and it is arranged appropriately or not, right? Or if it requires any retransmission, we will intimate the network layer and other lower layers to request for retransmission. The fifth layer is session layer, right? Session layer, as the name suggests, session layer is used to maintain or control the session related activities. For example, if you log into your bank account, right, at what time you have logged into the bank account, how long you have been logged into the bank account, right? Or if you have moved from your website to another application, right, the session will be controlled or maintained by the session layer. Or if you come back, it will be resumed from the last work that you have done, right? All the session related activities will be controlled or maintained by the session layer. And if you want to open the application after some time, it will give you the history of what you have done in the past, right? So the connection establishment, connection management, or connection termination related activities will also be handled by session layer. Then presentation layer. The main functionality of presentation layer is to ensure the security, that is encoding and decoding of the messages, right? Encoding and decoding of the messages. So basically the presentation layer will convert your message into unreadable format. So if any third person or hackers will enter into your network, try to hack your data, this presentation layer will ensure that your message is unreadable, right? Then the last layer, the seventh layer is the application layer. So the application layer is actually the interface for the end users or human beings, right? So there are a lot of application services are supported by the application layer. So these are not actually the applications, the main thing, right? But it will provide services for such applications, right? So for example, if you like if you take Word or Excel, Microsoft Word or Excel, it won't provide the self message. It can create a message by its own. You have to. It will provide interface for the user to create their messages, right? So it will provide the services for such applications, right? So this is how the overall summary of OSI model. See, we have discussed about the 7 layers of OSI reference model. The top 3 layers, that is application layer, presentation layer and session layer, will be implemented as a part of operating systems or software, right? The topmost 3 layers will be implemented as a part of operating systems, whereas the bottommost 3 layers, physical layer, data link layer and network layer, will be implemented as a hardware, right? Or it requires some sort of hardware support in order to implement the functionalities of the bottommost these 3 layers, right? As I said, transport layer will be the heart of the OSI reference model, right? And if you look at the second column, the PDU, protocol data unit, right? Protocol data unit. The data generated from the topmost 3 layers are usually called as data, right? Usually called as data, whereas when it comes to the transport layer, the PDU is called as segment, right? segment, and the PDO in network layer is called as packet, and the PDO in data link layer is called as frames, and finally the PDO in physical layer is called as bits. Right? And the functionalities in short format I have given in the third column. Right? Functionalities, it will provide the human machine interface. Application layer will provide the human to machine interface, and the protocols supported in the application layer is HTTP, FTP, SMTP. There are a lot of protocols. For example, I have given some protocols, right? And presentation layer, it does provides encryption, decryption, and representation of data format, right? Example protocols are SSL, secure cell layer, and transport layer security, right? The session layer, establishment, maintenance, and termination of sessions, right? Point-to-point tunneling protocol, session initiation protocol, session administration protocol, right? Net bias are some examples for session layer protocols, right? Transport layer protocols, segmentation, acknowledgement, functionalities are segmentation, acknowledgement, sequencing, and duplicate detection. Right? As example protocols are TCP, UDP, right? ICMP, IGMP. There are a lot of protocols in transport layer. TCP, UDP only are the examples for transport layer. Whereas ICMP, IGMP, EGP, border gateway protocols are examples for network layer protocols. The main functionality of network layer is addressing and routing. Right? The PDO in network layer is called as packet. Right? And data link layer PDO is called as frames. The main functionality is error detection, error correction, and flow control. And medium access is also the functionality of data link layer. Example protocols, frame relay, ATM, point-to-point protocols. And the bottommost physical layer functionality is hardware means of sending, conversion of data into suitable format for transmission. Example protocols are USB, Bluetooth, right? Bluetooth, other sample protocols. And right, you should not change the order hierarchy of the OSI reference model. So in order to remember the hierarchy of OSI model, you can use this mnemonic: please do not throw sausage pizza away. Right? The first letter resembles the layers of OSI model. Please do not throw sausage pizza away. Right? So thank you guys. This is the overall functionalities of OSI reference model. If you have any questions, please let me know. Okay, thank you.